So here's one of your practice problems. So, and by the way, so that document that I posted that says practice problems for final exam, those are just if you're interested in a little bit of extra practice. That document by itself does not cover all of the topics on the final exam. So just a heads up there. But just some extra examples that I threw together in case you guys want to work them for extra practice, or they were originally intended as potential questions to work in class if I ran out of questions from you guys. But anyway, so if you want help with question 3 and that set of practice problems, here it is. So we're supposed to assume that T is a linear transformation from R2 to R3, where the output corresponding to the input vector 1, 2 is this 1, 2, 1. And then T of negative 1, 4 gives us an output of negative 2, 3, 1. Now we're asked to calculate T of negative 5, 8. And here we're also given that vector, negative 5, 8, as a linear combination of these two input vectors. That's 1, 2 and negative 1, 4. So the idea here is to use the linearity of this transformation. So I would start with saying we should recall that T is a linear transformation. Could have written this before I started the video, but oh well. T is a linear transformation if and only if it satisfies two requirements. First, T of u plus v is equal to T of u plus T of v for any vectors u and v in the domain. And T of some scalar c times u is equal to c times T of u. We can pull out scalar multiples in a linear transformation. So the idea here, I need another color, is to use this equation and say T of negative 5, 8, which I would actually like to color code this. T of negative 5, 8 is equal to, according to that equation that we were given, it's equal to T of negative 2 times 1, 2 plus 3 times negative 1, 4. Because T is a linear transformation, sorry about the glare there. Because T is a linear transformation, first of all, so we've got a sum of two vectors. Thanks to this first property here, we can say that that's equal to T of negative 2 times 1, 2 plus T of 3 times negative 1, 4. And then, because of this second property, we can pull out those scalar multiples. So this is equal to negative 2 times, I'll write this next part in blue, T of 1, 2, if we pull out this scalar multiple. And then same thing here, pull out the scalar multiple. So this is plus 3 times T of negative 1, 4. And notice, so T of 1, 2 and T of negative 1, 4 are provided. So now we can plug in the given vectors. I wish my board was just a little bit longer here. But we can plug in the given vectors for T of 1, 2 and T of negative 1, 4. I'm going to position this as best I can, which is going to be in the middle of the board here. You may see what the final answer is here, so maybe nobody's watching this video at this point. But I'll finish it out. So this is negative 2 times T of 1, 2 is 1, 2, 1. Plus 3 times T of negative 1, 4 is this, negative 2, 3, 1. And so now we just have to do the vector arithmetic. So distribute the negative 2, distribute the 3, and then add the corresponding entries. So this is -2, -4, -2, plus -6, 9, 3, right? If we multiply everything by 3. And so that's equal to -8, 5, 1 for our final answer. But taking a step back, the overall idea is to use the fact that t is linear is what's critical here. So t of this vector is equal to -2 times t of this vector plus 3 times t of this vector. And then those values are provided.